Computing the equivalent resistance is illustrated in this example using an intuitive shortcut. In a brute force approach, when you want to find the equivalent resistance between, as seen from the port AB, you would just go ahead and simplify the circuit, and especially in this case, as you're seeing in these structures, triangular structure, you would convert them to star format so that you would be able to simplify them. But we can use intuitively a feature in the circuit due to its inherent symmetry. As you can see, when the current is flowing in this circuit, the upper portion, which is this portion, is exact copy paste of the lower portion of the circuit. Therefore, we can assume naturally that the same amount of current flowing through this segment of the circuit as this segment. And it's safe to make the assumption that the voltage here at this node Vx should be equal to voltage here at this node Vy. Therefore, there is no current flowing through this resistor. So the current through this resistor is zero. The same thing is applicable for this node, which is node, let's say, x2, and this node, which is node y2. You can argue that because of the inherent symmetry of this structure, whatever current is flowing through this way uh, is the same as the current flowing this way, and there is no current flowing through this resistor, and you can say Vx2 should be equal to Vy2. So there is no current going this way into this resistor. You can assume this resistor as it is not there. You can assume this resistor as it is not there. And the same thing about these two resistors. So you can assume that this resistor is not there, this resistor is not there, because effectively the voltage across that resistor is zero, and there is no current flowing through the resistor. With that in mind, the circuit can be therefore simplified as R series with R2R, R series with R2R. So you have this format. You have 2R, and you have 2R, which means in parallel, which means R. And then after that, we have R. As I said, we let go of this resistor, so we have R. And then we have 2R, and we have 2R for the upper branch. And then we get to this point that we have to connect them together. The same thing you can say about the lower branch as well. Of course, 2R in parallel with 2R becomes R. So for the lower branch, you have the same story. You have 2R, and then you have 2R, and then you have R and R, and again 2R, 2R, again for the same reasoning as we discussed, and they're connected to each other. Okay, with that in mind, we get to y and x point, and of course that resistor is not there, so you can make the assumption that you have just R, and you have another R, and finally we have the final R in series. Now everything is easy because the combination of these two guys in parallel is just R. So you get R series with R, another 2R, another 2R, another R. So all you can see is we get to this point that we have R, and then we have R, and for the bottom branch we have R, and we have R as well. And therefore, when you simplify the whole thing, you get 2R again in parallel with 2R, give you another R between the two nodes in the circuit. And that would translate again to overall impedance or resistance of R between the ports A and B for the circuit. This is port B, this is port A, because the question was asking what you see from these two ports. So all we see is now a resistor of 2R. Sorry, I just need to make a correction here because what we are seeing, let me make a correction. So we have this resistor R, and then we have 2R here in parallel with 2R, give you another R. And then we are back to port B, terminal B, which forms the port AB. And we are trying to find the resistor here, obviously is 2R, R plus R. So in summary, the equivalent resistance in this circuit is simply 2 times R. It's just a reminder that when you see these kind of circuits, before we jump into a brute force approach of computing equivalent resistance or equivalent impedance, it's always a good idea to observe a special symmetry in a given circuit, even though it's not a generic solution, but it's a good idea to observe the inherent symmetry and utilize it as much as possible. I hope that this is helpful.